Hey everybody, welcome back to the Metagrid. Today's video is dedicated to the Off-Grid Garage. It's a great YouTube channel. Check it out sometime. Anyway, we're doing an unboxing today, and I'm just going to explain a little bit about what we're doing with this item. So this is a Victron BlueSolar charge controller, MPPT 100/20 for specifically 48 volt systems. So I purchased the BlueSolar version, and it's kind of confusing with Victron, but the BlueSolar version does not have Bluetooth in it. So you can't connect to this unit with Bluetooth, even though it has blue in the title. It says BlueSolar. But if you want to connect to your charge controller with Bluetooth, you'll need to specify the Smart Solar version of any of these Victron charge controllers. Weirdly confusing, I know, but I have learned from experience that that's so. Yeah, so anyway, we don't need the Bluetooth because this will be connected to our Raspberry Pi with Venus OS. With this, and I'll be using this VE Direct USB cable to connect the charge controller to the Raspberry Pi that runs Venus OS, and we'll use that for all the monitoring and configuration, like we do with all of our other Victron items. So yeah, let's get into it. Yeah, I gotta say, I really enjoy YouTube unboxing videos. I mean, they seem kind of inane and stupid, like what's the point of watching somebody take something out of packaging? But I find it very helpful for stuff that I'm considering buying. I mean, you get an up-close and personal look at the thing. You get to compare the size to, you know, someone's hand. You get to see all the ports on the thing and the controls and whatnot, and get an idea of how well it'll fit into your life and your system and whatnot. And I thoroughly enjoy unboxing videos, and that's kind of why I make them. I think other people get the same information out of them that I do. So yeah, it's a small little unit. It's not all that big. There's a ground screw over here. We got the terminal hookups here. So there's a battery connection to your PV or charging source. In this case, it's going to be something other than a PV system that we'll hook this up to, at least initially. And then something that I haven't ever had on any of the other Victron charge controllers, but is on this charge controller, is a load control. So what you can do is you can configure the charge controller to turn on and off the load output depending upon battery voltage, I believe, maybe other items too, but the one I'm most concerned about is turning on and off that load, those load terminals with the determined by the battery voltage at the time. So that'll be fun to experiment with and see what we can do. They're not very big terminals, so what I'm guessing probably 10 gauge wire goes in there. I don't know for sure. I'll have to check the manual. There's a jumper here, and this is the VE Direct port, but there's a jumper on it that tells it what charging profile to use. And if you're going to use VE Direct and get finer control of the charge profiles, you'll remove that, you know, and then just hook up your VE Direct cable and use that to configure it. And again, you can't use Bluetooth like you can on most Victron items because there is no Bluetooth on this unit. It's the BlueSolar, so no Bluetooth. No Bluetooth for you, 1 year. So anyway, one of the things I'm curious about is this really a VE Direct port? So I'm going to just try this real quick. I'll take that jumper off, and lucky you, bonus unboxing today. Actually, unpackaging. It's our VE Direct USB cable. So here's the VE Direct the plug that goes right into the socket there, the VE Direct socket, and let's just make sure that fits in there because it's not labeled. And yeah, it does, it fits perfectly. So that's definitely a VE Direct port. So that should work fine. So what we're going to do with this is I have the system I'm at now that this is going to be installed in is a solar panel based system. And it's very close to our cabin, and it's got our new LiFePo4 batteries on it. And I have two other systems that are hydroelectrically charged, and they have a lot of excess power in the winter, of course, because there's a lot of rain here in the winter. In fact, we have about 2 seasons here, the rainy season and the non-rainy season. And during the rainy season, we have 6 months of rain, and that's pretty much it. So we make use of that, generate electricity with all that gravity that falls in the mountains. And but we have a bit of a problem. The hydroelectric generators are a ways away from where we're located here. So what I've got is a couple of 10 AWG UF cables running from those hydroelectric systems to this system here, and I want to be able to utilize that excess power to charge the batteries here when we need extra charging in the winter when there's very little sun. And so what I'm going to do, at least initially until I find a better solution, is I bought a CVCC power supply that can supply up to 120 volts DC directly from AC at about 83 or 84% efficiency. I've been looking around for a fairly inexpensive solution to provide it DC power a bit more efficiently than that, but this was cheap, and I want to get it going until I can figure out how to provide a more efficient conversion from AC from the other systems to DC here, which is what we need for this charge controller. So I'm going to hook up that power supply, and I'm going to put the output of the DC into the PV input here, and then that should just charge the battery. And the advantage to doing it that way is I can come into this unit and tell it how many amps to shunt to our existing battery here. So like if we have a dry spell of a couple weeks, perish the thought, I can crank down the amps a little bit and use more of the solar and a little less of the hydro, which probably wouldn't be available during that time. Or like in the spring when it starts getting a little bit sunnier and less rainy, I can do the same thing. Or, if we have a couple weeks of nothing but solid rain, which never happens around here, well, I can jump up the amps on the charge controller here and utilize a lot more of the energy from the hydroelectric systems. So I'm going to make a video of that once I get that working and configured and just show you how that works. But I've already experimented quite a bit with my large solar charge controller, and it works perfectly. My large solar charge controller is a 250 amp version, and I hooked up a full wave bridge rectifier to it, and boy, that did a heck of a number, but it output up to 200 volts, so I couldn't use that rectifier with this unit because this only handles 100 volts max. So and the efficiency on that full wave bridge rectifier ended up being about 92-93%, which was just right, but I need to find another solution to that's more efficient, that can only put out less than 100 volts, or wait until I have more money and I'll buy a larger charge controller than this that'll handle up to 250 volts. But boy, those things are pricey. So for now, we're just going to go with this and experiment with it and see how it works. So yeah. Why don't you come along and join us next time, and I'll show you a few more things about that. And then eventually here we're going to have a video on our completed battery. I got the battery all wired up. I got the BMS installed. Everything's working great. I had to put 3 helicoils in because I stripped 3 of the threads, as you'll see in one of my previous videos. But I can go over that when I get that video done. So anyway, everybody take care out there. I know it's getting crazy, but, hang together. And keep checking us out. Thanks a lot. Bye-bye.